19.2a, problems 3, most of problem 3, and parts of problem number 4. So number 3, we have the sequence. We'll fill in the table. The first term in the sequence is 8, so that goes here. The second term is the 32. The third term is the 128. And the fourth term is the 512. Well, if we look at it, we figure out that it's multiplying by 4 every time. So is this sequence arithmetic or geometric? It's geometric. Arithmetic is adding or subtracting. Geometric is multiplying or dividing. So because we're multiplying by 4 every time. What is the initial value of this sequence? So we need to go back to the initial value. 8 divided by 4 would be 2. What term number? It's term number 0. Find the value of t of 5. So I go to the fifth term right here, and I need to do 512 times 4. That gives me 2048. 2048. So to find the 50th term, if I want to keep doing this each time, that would be the style of recursion, to do it one at a time. Or what would be better is to find the explicit rule. The explicit rule is that we're multiplying by 4 every time. So we can go f of x is equal to the initial value, which is 2, and I'm multiplying by 4 every time. So there's an equation. We could use that for plug in for 50. If we plug in a 50 right here, we get a huge number on the calculator with this scientific notation. So I'm going to round that to 2.5 times 10 to the 30th. It's like moving this decimal over 30 times, or in a sense, if I just use a 2, having 30 zeros after it. The number 8192 is in terms such that this determine the value of n. So I want to plug something in here and get 8192 out. So I would do 8192 equals 2 times 4 to the x. First step I'll do is divide both sides by 2. And I get 4096 equals 4 to the x. If I convert this to a base of 4, 4 to what would be equal 4 to the x? So if the bases are the same, then I know that I just set the exponents equal to each other, or in fact I'll know the exponent. So at this point you just do a guess and check is what I would do. I would do 4, let's say start with the 20th power, 4 to the 20th. That's way too big because of the x scientific notation, so I try 4 exponent to the 10th equals, that's like 1,048,576, way too big, so I drop it down below 10 till I eventually find the answer. Considering this, so problem number 4, look at this sequence here, 4, 9, 14, 19. We appear to be adding 5 every time. So is this arithmetic or geometric? It's arithmetic because we're adding 5 every time. So if this is the first, second, third, fourth, the fifth term would be 24, and the sixth term would be 29. So there's 29. As you probably use recursion to find A6, state the recursive rules for this sequence. What is the initial value? Initial value, I'd have to go back to term 0. And what is the value of A100? So here, I did this to find the sixth term rather than figuring out the rule. It was easier just to add 5 and add another 5. So what we did here was t of n plus 1 is equal to t of n plus 5. I have to define it as t of 1 is equal to 4 and n is greater than 1. Greater than or equal to 1, I'm sorry. So there's my recursive formula. The initial value helps me find an explicit formula. So A naught, if I subtract 5 from here, I'll end up with a -1. So I could do something like t of n is equal to -1 plus 5n. So then I can plug in a 100 right here and calculate the value. That would be the easy way.